Good afternoon, everyone, and welcome to today's webinar, Value Streams from Fats, Oils, and Greases in Industrial Wastewater, brought to us by FPSA member Alpha Laval. Our speaker today is Todd Blaze, Protein Market Manager at Alpha Laval. I'm Dolores Lanza, Senior Director of Membership at FPSA. The webinar is being recorded, so for those of you that are FPSA members, let your colleagues who weren't able to listen to it today know that they have access to it in the member-only section of the FPSA website. They can listen to it at any time. Before I pass this over to Todd, just a few housekeeping items. All attendees are muted by default, but you will have the opportunity to submit text questions to Todd today by typing in your questions in the questions pane of your control panel. You can send them in at any time throughout the presentation, and we will address them at the very end. So thank you very much for your time today. Let's get started. Give me about 2 seconds to pass the controls over to Todd. Okay, Todd, I think you're all set.
All right. Well, good afternoon, everyone. It's a pleasure to talk to you today about value stream from FOG. Of course, that's fats, oils, and greases. In this case, we're talking about the industrial wastewater and recovery from there. I'd certainly like to take this opportunity to thank FPSA for the opportunity to give this presentation today. And with this, the value streams for FOG, I think that one of the key things with that is that we try to look at how can we optimize recovery, and in this case, in as many cases as we can, we want to look at how can we optimize recovery for profit. What that allows is certainly so that a plant can grow because the wastewater treatment plant is under control. It can allow for reduction of water use or recovery of water, and certainly allows for, let's say, the most efficient process we can get as far as each one of these facilities. So it's truly a look at the whole FOG management side. Again, this is Todd Blaze. I'm with Alpha Laval on the food side. I've been focusing a significant amount of my time in the protein market segment. I've a number of years into food and dairy applications and certainly in equipment sales. So this certainly falls within where my comfort zone is with applications. As far as the agenda for today, certainly we want to talk about the recovery of water or management of water in relation to the global state of emergency of water and usage. The food and beverage specific, where we can help manage in that category. And then certainly discuss why on-site wastewater treatment. What's the importance of that, or how can customers take advantage of that? Certainly that is by reuse, recovery, and reduction. Those 3 R's are very useful from a efficiency standpoint in plants, as well as how can we look at, can we actually pay for a process or pay for a project according to managing those. As far as the wastewater treatment for profit, we're going to discuss a case study today. We'll give some details as far as what we looked at and what we accomplished with that. We'll cover some with the wastewater solutions, some ideas, some different things that certainly build the case for how can we manage reuse, recovery, and reduction. The key thing that we want to focus is waste into product. Probably a good example for discussing that would be in the cheese whey business. Certainly in many of our lifetimes, we've seen cheese whey go from a waste product that was spread on farm fields to now the value recovery that you get out of the waste material in some cases exceeds the value of the cheese that's produced in those facilities. And that's truly how we try to look at a lot of these applications is where can we get the best results or the best value for some of these waste products. Coming next would be managing the waste of energy by focusing on BTU management from one end of a waste treatment to another to make sure that we can capture some of the BTUs that are existing there, and they certainly can be used in other parts of a process facility. Reduce and eliminating cost of waste, that's only natural as we try to make value out of some of the products recovered, that we are also managing the cost of waste. And then finally, the treatment of water and how it's directly tied to reuse and recovery. Simply because some of this water can be used for other parts of a process, other parts of a facility, simply by focusing in that area as well. Some of the macro drivers that we try to look at with this is certainly in many areas where the water is less available, or there may be problems with managing wastewater, is where there's population growth, which is then also leading to as a result of the globalization and the urbanization, changing economies. You take just the ability to process a specific food product as an example, and then export it across the globe. It does two things. It may help the water conservation in one area by that, but it also may impede the water conservation in another. So it's just trying to find balance with that. Climate change, certainly the change in the weather from one area to the next, and the use of water in those areas, we try to focus on that simply just as an example where some of this water could be used for irrigation or for chilling or those types of things. Our declining water quantity and quality, those usually go together. When the water quantity is dissipating, the quality of the water also becomes more of a challenge. So it's focusing in those areas. As far as food safety and quality, there's a lot of use in water for managing the quality of products in the processes. So it's making sure that we adhere to good food safety in order to reach those quality aspects. The increasing food and energy and water prices, that's always a focus, simply because things usually don't go down. So it's down to how do we manage things as they're going up so it has less impact on our environment and it has less impact on the facilities that are trying to implement. And then finally, when we're looking at the water conservation programs, we try to focus on top food and beverage companies simply because of the impact that they can have across the globe. When we're looking at the industrial waste and wastewater in relation to usage, one of the key things is that you see where food and beverage, where 33% of the share of the industrial wastewater releases in the U.S. are from food and beverage. That is one of the reasons that we're focusing in this area. I mean, that product can be used as an ingredient into the product, which means it has to be high quality. It can be the initial cleaning of those products from the beginning. So essentially, can be a fair amount of usage there. It affects the efficiency of conveying some of the products that are being processed. So we want to make sure that there's plenty of water available and it's good quality. And then finally, to be able to reuse some of that water for plant cleaning and that type of thing is a good aspect and a good reason to be focused in this area. If you look at the average water footprint of some of the products that we're associated with, if you take in the upper left the poultry, very seldom do you see a 2-pound chicken. So if it's a 4 to 6 pound chicken, it's certainly a considerable amount of water per bird, and that applies to any of the species that we're looking at, as well as the fruits and vegetables, and certainly some of our favorite beverages. But I think the key thing that we want to look at is how can we reduce that, or how can we reuse in those areas. So the question is certainly, why on-site water waste treatment? Why is that a good idea, or why should we be entertaining that as a solution? And one of the critical things is that many of the municipal wastewater plants, they won't accept some of the complex wastewater that these processors are using, or let's say disposing. And that being, if there's high FOGs, municipal wastewater plants don't want it. They want that cleaned up before they get it. And if it's not, it leads to the next issue, and that's to avoid charges. Surcharges are a critical thing for the location of food processing, as well as the implementation of efficiencies, is how do we avoid wastewater treatment charges. When we look at the recovering valuable resources from some of these main processes, again, there's a lot of really good fats that can be recovered. There's a lot of really good proteins that can be recovered that are today going to drain. And that is a focus that we have, and that is a focus that will continue to be in place for managing what's being wasted, as well as managing water. And then, of course, the minimizing water consumption is related to that, where we're just reusing in as many places as we can within a facility. Further on to the question of why we want to minimize waste for disposal. Certainly the disposal costs are a real problem, and when we want to focus on how can we reduce that, the number of loads per week, the number of loads per day, and then ultimately what we run into in many cases is the loads themselves. What is the moisture content, or what is composed in that waste? Will landfill accept it, or will it be allowed to be spread across fields? Our next focus with the why on-site is the BTU management. There's no reason not to use the available BTUs within a facility as much as possible, as long as it's economically feasible. The wastewater treatment capacity is, in many cases, can be a bottleneck on whether a plant is expanded. And if we focus on these items that I'm mentioning, in some cases it gives you the allowance where you can increase your process production of your, let's say, consumer products, so that then the wastewater treatment plant is no longer the bottleneck. As far as the cost-efficient production, that goes hand in hand. That's what justifies some of these investments. And then ultimately to reduce our environmental footprint, so that if we can make things smaller, that will be very helpful from an overall expansion standpoint, as well as a management of that area. The simple recovery process is reuse, recovery, and reduce. And that is certainly something that we try to look at continually, and that is, Can we get heat recovery? Are there products that we can recover and even be used in the existing products that are produced, or would they be considered byproducts? They all add value. And then finally, by going through this exercise and reducing the amount of water that is going to waste, we're reducing that load as well. The case study that we want to talk about some today is related to a poultry plant. And this poultry plant is unique in its own, where they have a kill facility or a kill plant and a further processing plant, or let's say prepared foods plant, we could even call it, for on the same facility. So the waste is going to drain from both facilities into one single wastewater treatment plant that's on site. One of the key things with that is, if you look at the examples of the product in this slide, you'll see that the one on the left has breading, which is its own process problem, as well as you can see that it's been cooked in oil, which means that there will be oil drippings, and that will be going to drain, or at least some of it. And then the one on the right is where that product may be marinated, or it might there may be other treatments that are involved in that one, as well as, and then continuing to that would be the kill plant, where can be blood and a number of the waste products that comes from a poultry kill plant. In this case study, when we looked at the slaughter plant and the usage in this slaughter plant, one of the key things is the total amount of water used, 1 million to 1.5 million gallons, which that's not extraordinary for a lot of these facilities. So it's a range that fits well with a lot of process plants across the country. I think the other part that is worth mentioning is in this breaded product is this flour and pastry. And I'll talk to you a little bit further about that further in this presentation. Certainly the water, this 1 million and 1.5 million gallons of water, is laden with fats, proteins, and carbohydrates as a result of washing, as a result of managing ovens. There's just a number of locations within a facility where ultimately this product can end up in the drain. The waste loads determined for this case study were, I'll say, the traditional, where it was BOD, TDS, COD, pH, and certainly what you would commonly see with any wastewater treatment facility. And with this study, one of the key things that we wanted to try to illustrate was the beaker of oil that you see. That's what's coming off from the system that we're processing. That's not a doctored product. That is something that is, you might say, straight out of the value recovery. And the key things that we wanted to focus on within this facility was the cost of operation for this, as well as how do we ensure the recovery is happening, and back to related to flours and all kinds of different things that are within the waste stream. In this process, we want to look at the dissolved air flotation, or the DAF, which is certainly common in many of these plants, where we recover the DAF skimmings from the primary DAF. This, of course, is then subjected to heat so that we can maximize the recovery of oil from the solids that are in this the DAF skimmings. And we have two different approaches with that. One is a three-phase decanter centrifuge, and the other is a two-phase decanter centrifuge with a vertical high-speed separator. Each one has its place according to the composition of these of the DAF skimmings. It has more to do with the recovery, and then as you see, the oil that's recovered is technical grade or feed grade. And what also is a good feature with this process is the processed water then is returned back to the DAF cell, or it can also go for evaporation for the essentially so you can end the process with no waste. That's a critical feature that we try to focus on when we look at the mass balance for these types of applications. The next thing is in this case study is the assessment and the revamping what to do next or how to expand. Because I think the key thing with this location was they wanted to expand their facility, which means they're going to put more load to their wastewater treatment. So it was, how can this be done, or how can it be paid for, is really one of the two key questions. And when we looked at the cost of disposal, the cost of disposal for the solids was $35 a ton, or so approximately $900 a truckload, and that was at two truckloads a day. Let's say the difficulty with managing truckloads is certainly managing the sludge, and that's the logistics and the weather, where there's only so many times out of the year that field spreading is something that's allowable or even acceptable for the farmers. And then the other part is if this has to go to landfill, its moisture has to be to a certain level, otherwise they may be interested in it, but they'll want to charge you more. And so it's really focusing on that, how to manage that. And then the other is to really add value to the rendering streams, or the sludge removal. Simply because when you look at it, if you can sell something, why would you pay something why would you have to pay to have it hauled away? So essentially it's the looking at this as a business instead of as purely as a cost of operation. As far as the further assessment, we looked at the reduction in the number of loads per week, where we brought it down from 10 all the way down to 2, which is certainly all hauling cost and those types of cost related examples. And then we have the recovery side, where we're recovering this oil or recovering this fat, and depending on the quality of the fat and where it depends on where it goes. But ultimately the exercise that we saw in this case was that we could recover $12,000 per load, or that would be the revenue stream for the fat, and experienced up to $160,000 a month in revenue as a result of this approach. Now, how do we get started? What did we look at? And these are the critical things that we looked at for this process, was to see what our DAF skimmings was going to look like, and then recover them, do some spin tests, and see the end result. This helps us with our mass balance to size the process, to size the plant, as well as to be able to predict the overall revenue for this type of application. in this case study, there were some of the things that were part of the customer audit just to make sure that they were managing the value of the recovered streams. Each load, or let's say that the oil recovered was had free fatty acid tests for each load to make sure that it was complying to where the next use was, whether it was animal feed. And if the free fatty acid values were too high, then that would be sold to biofuel or biodiesel application versus the feed. The fat itself, the moisture content, and then finally the pesticides and herbicides, so that we could be sure that anything that was going to be fed to animals was compliant from that side. And then, of course, your usual effluent wastewater audits, where it was BOD, COD, TSS, phosphorus, ammonia, pH, and biannually with metals. So in summary, what we try to look at is that the DAF recovery system generated revenue. So in the revenue that it generated was substantial enough where it was essentially a self-funding project, simply because of the type of recoveries that we were able to exercise. In this case, the solids were also sold as animal feed, so that essentially every pound of solids as well as every pound of recovered water could be sold for a value versus a hauling cost. So based on all of this, let's say the revenue and essentially the success of the approach, it's allowing for a production increase as well as managing profits on both sides, not only on the production increase or the process plant, but also on the wastewater treatment plant itself. There's many applications, of course, with the waste where we can bring waste to value. The poultry example is just one of those that we look at. We also look at the slop oil and oily waste where we can convert that to high value hydrocarbons within our processes. We look at where we can recover spent wash from ethanol. FOG from a process facility. Another one would be bacon grease, where there's very high value and high volume, where we can take advantage of that. Cold tailings recovery, the starch recovery from potato chip or from French fry production, that also can not only be a value on the front end, but it also can really reduce the amount of surcharges that may be applied to a facility from a municipal treatment plant. The treated wastewater, of course, is reused. If we can reuse it for irrigation or processed water for cooling towers, essentially the key thing that we want to look at within a facility is what BTUs can we recover, just like any other waste? How can we recover those BTUs? This next slide is a little bit busy, but in the same time, the key focus with it is we want to focus on need determines the technology, not that technology determines the need. Because there's a lot of different methods that we can look like for treatment and recovery, but the main focus that we're trying to accomplish is the use of equipment that will allow for the best return of value, not just in the byproducts recovered, but also in the amount of water that's reduced or reused. So it's totally looking at this the flows, and how can we concentrate in each area for the best success for the end user. And with that, we try to use a number of things for problem solving. If you look at the left-hand column, it's everything from your water use to your cake solids, how to reduce your polymer use, our unit capacity, what can we get out of each process piece of equipment, what's the power consumption. So it's really trying to take the usual operation issues, the usual focus for improvement, and applying that to each type of equipment to really try to determine what is the best potential solution for that location. And as far as the spectrum of components, again, we try to look at it from that standpoint where maybe MBR is the right example or the right application for that specific plant. Maybe it's not for the next one. It's all these types of scenarios that we try to dissect well enough so that, again, we focus back to what is the total cost and what is the total return, so that we can establish the best criteria for the success of these applications. Thickening might be something that we use, dewatering might be something that we use, and certainly looking at the heat exchange side or the BTU management side, that also is something that we may use. So again, when we look at reduce, recover, and reuse, we certainly want to reduce waste. In the same time, make allowances. How can we reduce water? And when we look at the value of products and the products that we can recover, how can we do that? Essentially, we try to look at the entire mass balance of a facility and what can we do for recovery. And usually what plays with that then is what can we do for recovery of water. And then finally, with the reuse, some of these products can be reused. Some of them can be made into something that's they might even be better than the ones that are on the front end. It's all down to focus. And then the other part is the water reuse. Can we use it in a chill water system? Can we use it as in a cleaning area? All these types of applications. And thank you for your time today. We are now available for questions for anything that you guys want to throw at us, and we'll see if it sticks.
Thank you, Todd. I do have a few questions. First one, is there a minimum size processor?
There is not. I mean, I mentioned the 1,000,000 gallons or the 1.5 million gallons size for in this case it was a poultry facility. As you can see with the value that's recovered, there is room to go lower than that. And then I would say also with some of the there may be some of these processes where the byproducts that we can recover are very valuable. And if that's the case, the capacity requirements would certainly be less in those cases. So essentially, we try to look at as many different scenarios as we can to come up with, is there a true return on investment there?
Okay, very good, thank you. Second question, how do I determine a market for my recovered byproducts?
That's always I'll say a tricky one for some applications, and others it's fairly straightforward. There is some commodity buyers, there is some brokers out there for some of these products, and then others it may not be so much, where the facility itself has to become proactive with developing sales contracts for the material. That's a case-by-case scenario that we look at, but certainly what we find is with effort, there's usually some pretty good results that we can come up with. It just is, it's not something that I'll say you'll just find on the internet or something like that. It takes a little more effort.
Okay, great. Next question, is there an equipment list for starch recovery?
We do have a equipment list for starch recovery. It wasn't covered in this presentation today, but yes, we have details on starch recovery, yes.
Very good. Okay. And what kinds of microfiltration products are used in the wastewater recovery process?
I would say that the answer to the microfiltration is we have a lot of different choices within membrane filtration, which means that you have the full range. You have micro, you have nano, and you have UF and RO. So it's really, for us, it's down to, let's look at the particle size and what we really want to manage with that particle size and with the membrane, because that's ultimately what those membranes do.
Okay, thank you. And finally, who do we contact for help at Alpha Laval? I have a feeling that might be you, Todd.
Yes, certainly my email and my phone number is there. Let's start there, and then I will bring each application and each location into whatever is appropriate.
Very good. Terrific. Well, looks like that is all the questions we have. Thank you, everyone, for your time today, and thank you so much, Todd, for this very interesting presentation. Again, it's been recorded, so anybody can re-listen to it at another time. Thank you again, folks. Appreciate your time.
Yeah, thank you, everybody.